Find the mean absolute deviation and standard deviation of the following data. The given numbers are 18, 15, 21, 16, 20, 16, 24, 17, 16 and 25. So we are asked to find the mean absolute deviation and then standard deviation. So we have a formula for this mean absolute deviation. It is, in short, we say MAD. So mean absolute deviation is equal to 1 over n, where this n is the number of data values. That is how many values, the numbers we are considering here. That is n. This is a capital sigma, which is the summation of all this. That is, we have to add all these values that are obtained by taking the difference between the variable and the mean. I'll show it to you in the next table. And this xi is the variable. Variable means the same, these numbers. We have those, what are these? 18, 15, these are all the variables. X value, xi goes here, those numbers. X bar, we read it as x bar, that is the mean. Right, so n is the number of items. Sigma, that is the summation, we have to add all those. In between is absolute value of xi minus x bar. Xi is one number which changes, that's what we call it as a variable. X bar is the mean of the given items. Right, so let us find the mean absolute deviation, then we'll come back to the standard deviation. So we have a table here. In the first column I entered the values, the given values 18, 15, 21 all the way up to 25. So those are the x values. Now to find the mean, you know that the mean is nothing but sum of all the items over the number of items. So on adding all these numbers from this 18 plus 15 plus 21 plus 16, take calculator and put them in the calculator and add them up. So you'll get 188. So it is 188 is the total of all those values. Now to find the mean, it is x bar mean is equal to, the sum is 188, divide the total number of items we have here, those are 10. 1, 2, 3, 4, 5, 6, 7, 24, it is 7, then 8, 9, 10. So 10 items are there, that's why I divide by 10. 188 divided 10 gives us 18.8. That is the mean of this given data values. So this mean is being subtracted from each of those x values. So here I will do 18 minus, I have to write here 18 minus 18.8. So from 18 I subtracted 18.8, gives rise to negative 0.8. So I just subtracted, I'll just show it to you. For 18, 18 minus 18.8 is equal to negative 8. Similarly, 15 minus 15 minus 18.8 is negative 3.8. 21 minus 3.8 is 2.2, I think. So you should go on subtracting these values from 18.8. I have done here already. You have 18 minus 18.8, you got that. 15 minus 18.8, then this 21 minus 18.8, 16 minus 18.8. Remember, xi is this. Those x values are the xi's, and x bar is the mean, which is 18.8. Sometimes you can just replace that x bar with the mean, whatever you obtain from here. It is same all through 18.8, 18.8. So after obtaining this difference between xi and x bar, those values, negative 0.8, negative 3.8, etc., all these 10 numbers, we have to add. On adding these differences, the values which are obtained here, this total must be equal to 0. If it is not equal to 0, we made an error somewhere, something went wrong, so we have to go back and verify. So let us verify by entering these values in the calculator. Now I have these values entered in the calculator. Let me show it to you. So these are starting from negative 0.8, right? So we have here negative 0.8, negative 3.8, 2.2, then negative 2.8, all the way entered in this calculator, and add them. So the result is a 0, because actually this is the mean. From the mean, those variables are being deviated on either side. Some numbers are less than the mean 18.8, and so few of them are greater than. So eventually the total of those differences will be 0. That is the thing. Now, to find the absolute mean deviation, I take these absolute values. That is, absolute value of this negative 8, negative 0.8. When you take absolute value, we only consider the magnitude, not the sign. Whether it is positive or negative, just note down its value. That is a 0.8. In this case, negative 3.8, but its absolute value is 3.8. Similarly, 2.2, just 2 point is by itself, I'll write off 2.2, and all these absolute values of the differences are written in my third column. So I have them here for you. So these are all absolute values already taken down. And after finding all these absolute values, what should I do here? I'll go back and add them in this third column. Okay. So now we entered all these values from the third column. That is 0.0, 0.8, 3.8, 2.2, etc. all the way up to 6.2. We entered them in this calculator. That is, I just changed the negative signs and made them to positive. That's, I deleted those negatives, and then the total became 29.6. See, on removing the negative signs from 0, it changed. Now my total of that sum of these mean absolute deviations is 29.6. So I'll enter the 29.6 here, and this last box, 29.6. That is the sum, like we have seen in the formula of mean absolute deviation. We have what it is, 1 over n, sum of all these deviations, xi minus x bar. Okay, so I have to substitute my answers, my values in that. Let me do it here at the bottom. So I have the sum is 29.6. So mean absolute deviation is equal to that MAD is equal to 1 over n sigma absolute value of xi minus x bar, that is 1 over 10 times sum of all these is 29.6. 29.6. So 29.6 over 10. That gives me the mean absolute deviation is equal to 2.96. That is my answer for MAD, my mean absolute deviation, right? Let us now find this standard deviation, the standard deviation of those numbers given to us. So the formula for standard deviation is this. So this is also sigma. The top here in mean absolute deviation, that is sigma, is an uppercase letter, and this other one is lowercase sigma. Square root of 1 over n and the sum of all these xi minus x bars. In this case we are squaring it, so we call it as sum of the squares of the differences. So add them up, divide by n and find the square root. If you don't find the square root, then it is variance. So variance is the square of the standard deviation. But in our problem here, we are looking for the standard deviation. What is the standard deviation? Alright, so let us go back to our table here. We already have the first, second and third columns filled in. Now we just have to fill in this xi minus x bar square. So we just have to square the difference. I can square directly this number or this negative 8, both are same. Negative 0.8 square gives me 0.664, or 0.8 square also the same thing, right? So let us square them. 3.8 square, that is 3.8 on squaring 14.44, and write 14.44 here, 14.44, 2.2 square, that is 22 square is 484, so 4.84. 28 square is 784, so 7.84, 12 square 144, so 1.44 decimal point after 2 digits. So all the way we have to square them, that I have here for you. So 0.8 square is 0.64, 3.8 square is 14.44, 2.2 that is 4.84. We got all the squares of these numbers. So after having the squares of all the numbers, I have to add them, right? These are the numbers I have. So let us go ahead and add my last column, the fourth column, put them in. Let us enter in your calculator. All right. So I'll start off with the 0.64, 0.64 plus, that is 14.44 plus 4.84 all the way up to that last number 38.44, right? So we have here, I already entered them in this calculator. It is total is how much? 113.6. So let me enter it in my last column here. How much? 113.6. 113.6. That is the sum of the squares of those numbers. Now let me go back to the formula. What it says here for standard deviation, I have so here sigma equal to square root of 1 over n summation of all this xi minus x bar whole square. So what are my values? That standard deviation, or that sigma, is equal to square root of 1 over 10. 10 is the number of items, times this xi minus x bar is 113.6, 113.6. So that gives me square root of 113.6 divide 10. So let us enter in calculator. Square root of 113.6 divide 10 is how much? 3.37045, etc. So I'll consider these two digits. My answer is 3.37. That is the standard deviation. 3.37. So this is how we can find the mean absolute deviation and standard deviation of the given data values. So given 10 numbers, first we have to find the mean. After finding the mean, find the difference, and afterwards absolute difference, add them up, divide by n to get the mean absolute deviation. But for the standard deviation, I have to square them also. I just have to square the values, add them, and then divide. Afterwards, find the square root. That's all. So please try one example. Thank you. Okay.